The outline of the glass block was drawn. The normal at 90 degrees was drawn using a protractor, and in this case an incident ray with an angle of incidence of 40 degrees, always measured to the normal, was also measured with a protractor. Okay, so we now need to find the angle of refraction, so we place the block back on there again. Okay, we get our pins. Okay, so you're explaining this, you just say using pins. So you put your 2 pins on the angle or the incident ray like that. Okay, you look in here. Okay, you look in here and you find you put a 3rd pin in so that it's in line with those 2 pins. And then you put a 4th pin in that it's again in line with the 2 pins. So when you're explaining this in your question, you're saying, using pins, I found that the path along which the light ray travels. So we take away the glass block, we have our 2 pins. Okay, take them out. Okay, we join these 2 positions, so this was the ray that came out. So the emerging part here. Okay, that's the emerging ray, and we know that as it passed through the glass block, it travelled in a straight line. So we can join those like that. Okay, so using pins, I found the path as it passed through the glass block, and you would draw a diagram like that. Okay, you then say I measure the angle of refraction, which is here, not down here. The angle of refraction is this one. So this is effectively the refracted ray we're interested in, the refracted ray coming from air. Okay, and we measure that again with a protractor to the normal again, So we put it in like that. Okay, and I'm getting a value here of 24 degrees. Okay, right. And then we repeat this for 1, 2, 3, 4, 5, 6 different angles of incidence, 5 different angles of refraction, and we draw a suitable graph, which we know is a graph of sin I on the y-axis against sin r on the x-axis, giving us a slope equal to the refractive index. And that's it. Very good.